everyone. I got a couple emails from people who were a little confused on how to set up the graph for the photosynthesis and cellular respiration lab. So I thought I'd record a short video for you explaining this kind of graph and how to set it up. Now, for the AP Bio exam and for this course, it's probably 6 or 7 different kinds of graphs that you absolutely must know how to do and how to interpret. And this is one of them. And this is what's called a dual y graph because it has 2 y-axes and 1 x-axis. Now, for this particular experiment, our x-axis is going to be time. It's going to be in 5-minute intervals from 0 to 30. And you always, always, always put your units on your graph. If you're asked to make a graph on the AP exam and you don't put units, you probably will not get any points at all for that graph. We have a saying in AP Bio, and that is that, what do we call a graph without units? Meaningless or useless. Okay, so you got to put your units. Now, for this particular graph, the dual y-axes, one is going to be pH. Let's talk about that first because that's easier, right? So I've got pH here. I've got even intervals starting at the lowest one on the scale we have, which is 6.9, going almost all the way up to the top to 9.1. I should have left myself a little bit more room. And how are you going to find the pHs? You're going to look at the colors of the tubes in the video and see which one of these colors it matches the most closely, and that's going to be your pH reading at that time point, okay? Now, the other y-axis is going to be absorbance. Let's talk about what that means for a second. Absorbance is measured with a machine called a spectrophotometer or a colorimeter. And what that does, that kind of machine shoots a beam of light at a specific wavelength, and here it's 550 nanometers, and it shoots the beam through, and then it measures how much light gets through your liquid sample as compared to how much light entered the sample. How much light gets through the sample as compared to how much entered it. Now, if 100%, if all the light goes straight through the sample, if the sample did not absorb any of that wavelength of light, the absorbance would be 1.00. If none of the light makes it through that sample, the absorbance would be 0. Okay. Now, you can also have negative absorbances. Now, what the heck is that? Okay. The opposite of absorbance is reflection. Okay. So if you've got these negative numbers here, that means that wavelength of light is reflected. Now, where would you see that in nature, and how does that relate to photosynthesis? Well, green light. Leaves are green because they contain chlorophyll. And chlorophyll does not absorb green light, it reflects it. Chlorophyll, the color something appears is the opposite the color it absorbs. Okay, so the color something it appears is the color it reflects. Okay, so if you were doing like a little science experiment in middle school or elementary school where you grew plants under different colors of light, that's a classic elementary school science fair experiment. Green would be the worst color to put the plants under, at least for a green plant, because none of that light would be absorbed and used in photosynthesis. It would all be reflected. Now, where did these numbers come from? Now, I'm going to zoom in on that color card that we have. Okay, and if you zoom in on that color card there, let me just refocus this so you can see the numbers a little better. Let's see. That's a little better. If you zoom in on that color card, for each color on the color card, they give you a pH and a corresponding absorbance. Okay, so a wavelength of 550 nanometers will go 100% through the sample with 0 absorbance at around a pH of 8.1, which would be that color. Okay, so all I did here on my graph, I'm going to zoom back out, is I just took the corresponding numbers for absorbance for each of the pH readings we had and put those absorbance numbers on the second y-axis. So a pH of 6.9 corresponds with an absorbance of negative 4.85. So at that same point at the y on the other y-axis, I've got that number. So that's how you set up those axes. It's really important to understand the color something appears is the color it reflects. And if you want efficient photosynthesis, you want to give the plant a color that it will absorb. Okay, so we've got these numbers here. And then once you've got your axes set up, that's probably the hard part. You're going to graph your data, and you're going to have two lines on here. One for the tube that was uncovered and left in the light, and one for the tube that was covered with foil and left in the dark. Now, I use two different colors. If you don't have two different colors, that's okay. Another way you can do it, I use circles for the data points for the light tube and squares for the data point for the dark tube. Now, both tubes started out at the same color before when we started the experiment at time 0. That's why both lines start at the same time. And as the lab proceeds, the tube that's kept in the dark cannot do photosynthesis because it's not getting any light input. So what's the only process that tube in the dark can do? That's right, cellular respiration. And cellular respiration creates CO2, which turns into an acid when it's mixed in water and lowers the pH. So the dark tube over time, you should have a line that is sloping downwards. Okay. The light tube, however, is also going to do cellular respiration. Every living thing's got to do some form of cellular respiration, but it's going to do photosynthesis. And the balance there is that tube's going to do more photosynthesis than cellular respiration. So there's going to be a net absorption of CO2. So CO2 levels are going to go down. So it's going to become less acidic. So that line should go up over time. Now, I just made up these data points. I don't remember exactly where the data points were in the experiment in the video where you're getting your data from, but you're going to have one line going up and one line going down. Okay, so let's just summarize. A dual Y graph, two Y axes. Always put your units, okay? And the two y-axes in this particular experiment are pH and absorbance of 550 nanometers, okay? And you get the absorbance numbers from the corresponding numbers with the pH on the color card, okay? So I'm hoping that helps, and have